Hi, NA Physics, it's Mr. Neff. Today let's talk about convex spherical mirrors. And before we do, what kind of tea did the American colonists want? Of course, I'll tell you at the end of the video. On the last video, we were talking about plane mirrors, a flat mirror. Now we're going to talk about a spherical mirror. A mirror that's a ball, a sphere. It could be the entire ball, it could be just a portion of the sphere. Look at this piece of art. Looks like it's on a college campus somewhere. It's a huge sphere of mirror. You could have that whole thing. You can see in there, you can see some images of some trees, a building, the rest of this patio. It's able to form an image. That doesn't look like a plane mirror. Even though this is just a flat picture, you can tell that this mirror is not flat. This is not the way most images look, the way that you've seen them. Here we've got a person in front of a convex mirror and a concave mirror. The convex mirror is whenever you take a slice of that sphere and the outside of it is mirrored. It's going to give you that convex shape. Concave is going to be when the inside of that sphere is mirrored. And you can see that it gives you two very, very different looking images. It's the same guy, but over here he looks one way and over here he looks another way. Now that brings us to one of our first points. So with mirrors, we will very often put attributes on the images. We'll either say that an image is real or virtual. What does that mean exactly? A real image is one where light rays are actually crossing to form an image, versus a virtual image is one that's all in your mind. You'll see imagination lines crossing to form a virtual image. More on that in a second. Upright or inverted, you probably have a good sense of what that means. Upright means it's pointed the same way as the object is. Inverted means upside down. When you look at these images of this fellow up here, both of those images are upright. His hair's on the top, his chin's in the middle, his chest is on the bottom. You can't see his hair up here, but it's up there at the top. You can see that he's pointed the same direction. You might say, isn't that always the case? No, it's not always the case, actually. It's not the case a lot of times. And then magnified or reduced. You know what that means too. One of these images is magnified. It's this one. This one, we might say, has a magnification of, well, how many times bigger is that image than the real guy? Maybe it's 2 or 3. Look at this one. How many times bigger is this image on the left versus the real guy? It's no times. It's a fraction. We might say this magnification is, I don't know, 1/3 or something like that. And all of that happens because of where he is, but also because of the curvature of the mirror. So that's one of our skills, is we want to be able to put on any image, either real or virtual, either upright or inverted, either magnified or reduced. So we're going to pick 3 of those descriptors to put on each image, one of the red ones, one of the blue ones, one of the brown ones. Something that's going to help us, a tool that people have used for a long time on all kinds of mirrors and lenses, are ray diagrams. Now, if you watched the video on the plane mirrors, you saw that we have been drawing some ray diagrams, and those were good, but these are going to be very, very good. So you can see that ray diagrams are these simplified pictures of just a few of the many, many light rays that are coming off of an object. Here I have an object that's an arrow, an arrow. See, the arrow is the thing that we're very, very often going to draw the image of. An arrow is popular because it's got a definite top and a definite bottom. And you can tell them apart very, very easily. And so here's a ray diagram on the left of a plane mirror. Here's one for a convex mirror. Here's one for a concave mirror. Later, we're going to do them with lenses too. Here, we'll call this a converging lens. We'll call this a diverging lens. And so this is going to be a real skill that we have. This video is just going to cover the ray diagram sort of in general, and then the particulars for the convex mirror. Now, we've got 2 different kinds of objects. Objects that make their own light, luminous ones, and then objects that reflect the light from the environment. illuminated objects. And so things like candles and light bulbs in the sun are luminous objects versus things like people, this nifty dog holding the flashlight that I found, illuminated. Those, you turn the lights off, you're not going to see these people, you're not going to see this dog. You turn the lights off, you're still going to see those luminous objects. Regardless of whether it's illuminated or luminous on its own, it's going to send out tons of light rays. And we can think of those light rays as straight lines that sometimes encounter a mirror or a lens and get bent. So there's tons and tons of light rays. Look at this candle. And there's all these light rays coming off, and there's actually so many more there than what you even have pictured there. Just a few of those light rays are shown leaving this candle. Some of these light rays are hitting this convex mirror. Now, every one of those that hits that convex mirror is going to get reflected. Now, can you see how they would get reflected? Think about that for a second. Well, yeah, they would get reflected based on the law of reflection. And so there's like take this top one. There's an angle of incidence, you can see it right there, and then there's going to be an angle of reflection, and those two are basically going to match each other, definitely going to match each other, okay? And I could go ahead and do that for every one of these light rays, like this, and the place where I found this, they went ahead and did it for me. Let me get some of my junky pictures off of there. And so you can see that every place it reflected, it obeyed the law of reflection. Now, for me to really make a great picture, you could see that I made an okay sketch just a second ago, but for me to make a great picture, I'd have to have a protractor, and I'd have to really, really take my time. And I'm okay with that, but at the same time, I do know a quicker, easier way that you don't actually have to measure any angles, and I think you'd be interested in that. So the easy way to locate an image formed by an object in a mirror, in a lens later, is to use 3 light rays that I call straight edge friendly. As long as the thing is straight, you don't have to. It doesn't have to be able to measure angles. You don't have to have a protractor. You could just use any straight edge, and you will be able to successfully draw this. I said there's 3 rays that you're going to draw, and you can see I give them names right here. I have a parallel ray, a focal ray, and a chief ray. So I'm going to draw our first ray diagram now for a convex mirror. And so look at what I've done. First thing I've done is I've drawn this straight line right here, and we're calling that the principal axis, of course. It goes straight across the middle of my page. Now, I have drawn a portion of a sphere, a portion of a circle here. I've marked the center of it. Right here, you can see I mark it C for center of curvature. Now, halfway between the center of curvature and the vertex, remember this spot right here, we call our vertex, the place where the principal axis meets the mirror. Halfway between the center of curvature and the vertex, we put our focal point. For a spherical mirror, you'll always see that that focal point is halfway between the center of curvature and the vertex. So the focal length, we say, is half of a radius. Okay, now I need an object that I can get an image of. And so the object is going to be this candle. Arrows are popular, candles are popular too. I like a candle because it makes its own light. It's got a distinct top and bottom, and it's pretty easy to draw. So now, there are 3 rays of the many, many, many that come off of this that I'm going to trace along. The first ray that I always draw, and I'm going to encourage you to draw this one first, is called the parallel ray. Now, the parallel ray is the ray that just happens to leave the candle flame parallel to the principal axis. And so I'm going to draw that one in here now. You can't see me doing this very well, but I am using my straight edge. I'm trying to draw a pretty good picture here. That's okay. And I drew that so that it was parallel to the principal axis. Now, the way that reflects is it reflects listening to the law of reflection, of course, but I don't need to measure any angles. If I reflect it as if it has just come out of the focal point. So I am lining up with my straight edge right now, this point where the parallel ray hit the mirror and the focal point. You don't see my straight edge along here, but this is how I've drawn it. Okay? And so if I went ahead and drew in the normal line there, which of course would go through the center of curvature, I'm going to draw this now and then I'm going to back it off in a second. But if I went and I drew in here this normal line, that of course, as I say, goes right through that center point, you can see that the angle of incidence and the angle of reflection match each other pretty well. Okay, and notice I got those to match each other pretty well without really measuring any angles or anything like that at all. There's my parallel ray. Now my second ray that I'm going to draw is my focal ray. And the focal ray is the one that leaves on such an angle that it would go through the focal point if it could get back there. It doesn't get back there because it hits the mirror. But right now I am lining up with my straight edge. I'm lining up the candle flame and this focal point, and I'm drawing this ray right in here. Okay. Now, and I'm going to back this off in a second, but if the ray could just get right through the mirror, it would go down there and hit the focal point. But the mirror doesn't let anything through it, so it cannot. Now, that one reflects parallel to the principal axis. So a lot of people like to say, oh, the one goes parallel, then out like it came from the focal point, and now this one goes in like it's going to the focal point, and then out parallel. And that is correct. And so here is our focal ray. Now, you're going to be standing back here. This is you. And you're going to say, well, look at those light rays. Look at that red and that blue. Those are never going to cross. You can see that they're diverging with each other. Well, your eye's going to notice that, and your eye's going to say, oh, well, those two seem to come from a place that's way back here. Now look at what I'm doing. This is what it seems like is happening. I am drawing that with dotted lines. That's the convention all over the world, that things that you're just imagining are drawn with dotted lines. Okay, there they are. You can see that those two seem to be coming from this point right here. And guess what? That's where the image is going to be. There's one more ray that I'm going to draw on here, and it's going to be the chief ray. Now, the chief ray is the ray that has zero angle of incidence and zero angle of reflection. And so you can imagine that that's just going to go right in along the normal line. That is, it's going right in along the line that would go right to the center of curvature, and then it reflects right along that. If it has zero angle of incidence, it's also going to have zero angle of reflection. And so there's my chief ray. And I feel pretty good about this picture because, look, all three of those imagination lines all cross right there at that spot. So you see something? Right there is where that image of that candle is going to be. Draw it in something that looks a little bit like the candle. Now, I could go through the same thing, but there would be tons and tons of overlap, and the picture wouldn't look very good. I could go through the same thing with the base of the candle. Turns out the base of the candle always ends up right on the principal axis. And so there's the image. So we were going to say that this real candle is our object, and this candle right here is our image. And one thing that I can see for sure is, number one, that image is virtual. It's virtual because it's behind the mirror. It's virtual because it was formed by imagination lines, not real light. So I have an image that's virtual. I have an image that's reduced. Look how little it is compared to the size of the candle. It's reduced. And I have an image that's upright. The real candle has a flame on top, and the image has the flame on top. So it's upright. Now tune into the convex mirror number 2 video for the answer to the joke And one more example.